Hello, and welcome to the Sleep Science Podcast. I'm Penny Lewis, a neuroscientist specializing in sleep and memory and the presenter of this show. In the podcast, we talk about all things related to sleep, from dreaming and sleepwalking to what sleep does for our brain and body and how we can get more out of our sleep. Today, we're going to look at how manipulation of memories during sleep can be used to alter our mental schemas in ways that are beneficial. For instance, by tackling some of our unwanted prejudices or making negative memories more positive. My guest today is Professor Xiaoqing Hu of Hong Kong University, who's done groundbreaking research in this area. Much of this work uses targeted memory reactivation, which is a novel method for triggering memory reactivation in sleep. Memories are paired with specific sounds during wake, and then those sounds are used to trigger reactivation during subsequent sleep. Xiaoqing, welcome to the show.
Thank you, Penny. It's a great pleasure to be here.
You've done so much work in this area that I don't think we can cover it all, but we should surely start with your groundbreaking study of implicit bias with Ken Paller. Would you mind, explain the study, explain what you did, but maybe also explain what led you to do that study?
Yeah, so first, the implicit bias is prevalent. So when we use this kind of test known as the implicit association test, people tend to be faster in pressing one button, in the case of gender stereotype, like female with humanity and arts and male with science engineering. So this is one type of gender stereotype. So even though people may endorse gender egalitarian verbal report or on the questionnaire, they can still show this kind of subtle biases as reviewed by reaction time. So in my study, I first train people counter-bias association to strengthen the counter-bias association. That is to link female faces or name with science engineering words. With this type of training, people will get faster and then reduce the implicit biases. But the problem is this training can be labile. So that is, if you test people immediately after the training, after the counter-bias training, they will show reduced implicit bias. But if you invite the participant back to the lab, after 3 days, 5 days, or 1 week, the biases can return to their baseline level. So this led us question, how to stabilize or consolidate the counter-bias training effect. So then we come to the idea of sleep and the targeted memory reactivation. So we combine our counter-bias training procedure and with the targeted memory reactivation. So we had a sound, to be linked with the counter-bias training. And then we play the sound over and over again to the sleeping participant during their slow wave sleep. And after the wake up, we test the implicit biases again. And after 1 week, we test the implicit biases for a third time. And what we found is that the TMR, they reduced the biases immediately after they wake up, but also the training benefit persist after 1 week.
This was a really different study than most of the other studies using targeted memory reactivation at that time. So I think it was fairly early in the development of this technique. We'd only had a handful of papers where we actually triggered memories to reactivate with sounds, and most of them focused on simple memory tasks like picture placement on the screen. So the idea of using this to tackle implicit bias was really quite a creative insight, I would say. And I'm just curious where that came from, how you thought of this.
So actually, it all dated back to the beginning of my graduate school. So, when I entered the graduate school, I never thought I would study or research sleep. So my top research topic was memory detection. So whether we can detect a concealed memory, memory people want to hide. For example, in the deception detection field, it can be the knowledge related to a crime scene. And back at the time, there is behavior task known as autobiographical implicit association test. So basically try to review, whether we can use reaction time and the implicit association test to review which autobiographical event people had stored in their mind. So this is not about implicit bias at all. So back then, my research interest was whether people can voluntarily control their behavior in the autobiographical implicit association test. So then I basically use different kind of strategies like training and instruction to tell people to change their behavior in the IAT. And it appears that people are quite capable of changing their IAT performance. But then the question is, are we only changing their performance, or are we changing, the implicit associations, which is more like a mental construct? And as you know, the IAT was first developed into the prejudice stereotyping literature in the implicit social cognition. So after my study with the autobiographical IAT in the domain of deception detection, then I thought maybe I can use a similar method to train people to reduce implicit biases. So then I started to collaborate with Professor Galen Bodenhausen. So he's an expert in implicit social cognition, implicit prejudice, and stereotyping. So while collaborating with him, we collected data like hundreds of participants on how we can reduce implicit social biases with different types of counter-bias training strategies. And basically, that's how I get into the topic of training to reduce implicit biases. So we found that training worked immediately, but after we brought participants back after 1 week, so there's not a long-term effect. So that was a puzzle question for me, how to strengthen it, how to make it longer term. And what's interesting that I never end up publishing that data set. So although, I spent like 2 to 3 years collecting hundreds of participant data with the behavior test of the IAT, with the counter prejudice, counter stereotyping, but I never end up publishing the data, partly because one of our research questions is whether the counter-bias training can have a long-lasting effect. But I think the thing is that we did not stop there, and we keep thinking how to make the effect long-lasting. One way is obviously we can prolong the training, right, to add more rounds of training, which theoretically and intuitively should work. But also some other ideas by a coincidence, and I was in the seminar class, the memory, so taught by Compeller. 2009, he published his work on targeted memory reactivation, strengthening spatial memory. And that's also the year I entered my graduate school at Northwestern. So but when I first heard the study, I never thought, it could be linked with counter bias training. But 2 to 3 years later, around, I think, 2012, when I was about to do my comprehensive exam, in our PhD system. So I choose a topic. One topic is implicit social biases. Another topic is sleep and memory consolidation. So in the summer, I basically read like hundreds of papers in each of the topic. I guess, all of this intensive reading maybe implant some implicit associations between the idea like sleep and the counter-bias training. And then I also regularly go to Ken's office hour and also be in his lab meeting. And where this discussions, maybe we can try to strengthen the counter-bias training effect during sleep via TMR. So that's, how the idea come from. But then, because I still need to finish my PhD thesis, which is not related to sleep, so I need to put the idea aside and work on my PhD thesis data collection. But then I think another critical time point is 2013, the paper by Honor, also from Northwestern, on the fear extinction and TMR and sleep. So I think, that's kind of, again, a big move forward, right? To kind of not just to strengthen certain memory, but also try to weaken the unwanted ones. And there's also the conceptual link between fear and implicit social biases. Then I realized probably I need to hurry up with the idea, but still I need to finish my PhD data collection first. So I was busy with data collection for my PhD thesis, but in the same time, still contemplating on the idea how to, come up with a feasible design. And then after I defended my PhD thesis, I finally have the idea and a specific experiment design for the study. So in the summer of 2014, I finally have the time to go into data collection.
I mean, in my experience, that's the kind of trajectory of most of the experiments that, you have the gem of an idea, but then it's a very long process before you actually finalize the design. And it sounds like the fact that you were doing a PhD on implicit bias, was critical here. I hadn't actually realized that. I thought you did your PhD with Ken. So I haven't looked carefully enough. But that explains a lot, actually. It explains, you say you were already thinking about implicit bias, and then you came across the sleep memory work with Ken, and then you thought about how to integrate. And I would imagine the fact that you're writing up your PhD and analyzing all those data and thinking about all those methods really allowed you to refine this idea and decide which protocol to use and which task to use. And yeah. Was there a reason why you went for the specific IAT that you chose?
Oh yeah, IAT is probably one of the most cited tasks and the most widely used task in the implicit bias literature. Because it's based on like response conflict. There are so-called congruent versus incongruent blocks, so which typically give people very large effect size. So it provides us the basis to do further manipulation, right? So if the initial effect size is large, then if we want to play around with it, say reduce it, and then to see the effect we want. So the effect also tend to be large. And another thing is, the counter-bias training, the effect can also be large, at least immediately, because people really respond to these counter-stereotypic associations. And if you test them immediately after the counter-bias training, they will show a reduced score on the IAT. So basically, we're very confident based on my, the unpublished data set with hundreds of participants being tested. And also on many other studies, we know that the counter-bias training on the IAT task can work very effectively. And we can get kind of like a moderate to large effect size when we use this kind of task.
So it's a very strong manipulation. So can we, just for people who are listening who might not have come across the IAT before, I know you explained it, but could you maybe give an example of what a trial would look like? What actually happens in the task?
Yeah, sure. So in the IAT trial, you will be presented with one word, like in the center of the screen, say like a female face. And then your task, in one block, it can be press a left button for like a female face, press a right button for male face. Okay, so this is what we call simple categorization. And then in the next block of trial, your task is changed to press the left button for science-related words. Press another button for art-related words. This is again simple categorization. And then the task become complicated, what we call like double categorization. So now you need to press the one button, say the left button, for female face and for science-related words, and the right button for male face and the art-related words. So basically, you are pressing one button for two concepts.
And then you manipulate whether those concepts are typically congruent or incongruent. Yeah.
Yes, exactly. So after this, what we call double categorization block, participant will conduct another double categorization block. Basically, we switch. So now, for example, you need to press the left button for female and art-related words, and the right button for male and science-related words. So a typical pattern is that because people's mental associations, it's just like the classic priming effect, right? Like the butter, bread, be faster, when you press the button to detect bread after the word butter. So here, you'll be faster if the left button is male and science-related words. But you will be slower if the left button is for male and art-related words. So basically, by calculating these reaction time differences and also error rate, so people are more likely to commit more errors in these incongruent blocks. So we can calculate index for implicit biases.
So we know that you were able to counter these implicit biases with the targeted memory reactivation, but what did you actually reactivate in sleep?
So good question. So here, what we first have after this IAT, we'll ask people to engage in the counter-bias training task, basically to ask people to be faster and more accurate to press a button for like a female and science-related words. This is to strengthen, the associative link between the female concept and the science concept. And people are, again, quite capable of doing that, especially, we give them like, say, 2 to 3 rounds of training. So they will be faster and more accurate. And when they do this type of training, and when they press the correct button, we'll play auditory tone to the participant, kind of like, the feedback signal for a correct and a fast response. Because we give a response deadline, so if they give a slow response, we'll not provide the feedback. Again, this is to strengthen the association and also to pair the sound with that counter-stereotypic association. Then, during sleep, we replay this auditory tone to the sleeping participant during their slow wave sleep. And because the sound was associated with fast and accurate counter-stereotypic responses, we thought this would reactivate the counter-stereotypic associations.
Now I see exactly. So you're reactivating when they got it right. So this really opened the floodgates for the idea that this targeted memory reactivation is not just about strengthening memories, but it's actually about altering or updating memories. I know updating is the word that you use a lot. And I know that you've done lots of work on lots of different kinds of updating ever since then. I'm not quite sure where to start with it, but I think the first thing I would ask is, in this particular study that we've been discussing, I know that you found that the extent to which this reactivation was effective was actually predicted by the product of REM and slow wave sleep time. So neither of them individually, but when you multiply them together. And that's something that I know people have thought about the product previously. Bob Stickgold talks a lot about the product and how that means these sleep stages are interacting. But what are your thoughts on why it was that product rather than just the time in slow wave sleep?
I think, going back to the question, we talk about memory consolidation and slow wave sleep. But then, people will wonder what's the role of REM sleep, in the memory reactivation and consolidation. And I think nowadays people become more realized, we need both stage. Probably they have different functions, give the very different, distinct brain activity and also the neurochemical environment. So they must do something differently, but they may need to work in synergetic manner to help consolidate, what we learned before we sleep. And indeed, when we found that index, we found that years ago, people have used this index to explain variances in different types of learning. And also there are some other reports in like lexical learning and implicit learning. So I think, this result is consistent with this literature. Even in our recent work, in many of our study, sometimes we'll look at ourselves and sometimes, prompted by the reviewers. So because our manipulation most of the time is in non-REM sleep, but sometimes we found the effect of the REM sleep. And by putting them together, they can better explain the behavior. Like in our recent work, recently accepted at psychological medicine, we compared between healthy sleepers and insomnia sleepers. And we found that it's only among the healthy sleepers, so the product of slow wave sleep and REM sleep predicted over time emotional memory decay and emotion decay. So basically, as time passes, so we feel less strongly about negative memory. But in insomnia sleep, there is no such relationship. This is, again, the evidence suggesting that we need both sleep stages and to help us process the memories in an adaptive manner.
I mean, I would absolutely agree. And we find the same thing, by the way. And we, even in some of our most recent unpublished data, we find that it's that product actually predicts the impact of targeted memory reactivation in REM as well. Of course, this depends on the task and the study, but we do find the same thing. So it does seem to be that even if you start the process in one particular sleep stage, it continues to unfold across the subsequent sleep stages and probably across wake. And unfortunately, like everything, it's always more complicated than we would like it to be. So no, I wanted to ask about it because I think that was the first TMR study which looked at this product. And so I think, there were a number of firsts in that study. One was the fact that you were looking at bias instead of just memory strength. Another was that you followed it across time. I believe you were the first study to look for effects lasting over more time, and also that you looked for the interaction between this slow wave sleep and REM sleep. So, it was really a groundbreaking study in my view. Then the fact that you had now opened the door for more studies of updating, for more studies of how you can change how people's mental schema, so how people feel about themselves, how they feel about others, their biases. Can you tell us a bit about some of the other studies that you've done to look at those kind of questions?
Oh, yes, sure. So since I joined the University of Hong Kong, starting my own labs, looking more into emotional memories. And we look at emotional memories in two types. One is the typical in the episodic memory paradigm, like a cue target associations. Basically, the cue can be like a word and the target can be like a aversive image. For example, a neutral image and aversive image, like a scene showed like a car crash, something like that. So people feel aversive and negative reactive. So this is one context. Another scenario we study negative memory, emotional memory, is people would say is more ecological valid, which is to use lab analog trauma exposure. So basically ask a participant to view like trauma film. So it is a film, but, when it is unfolded in front of you, it can elicit this kind of a trauma-like responses. So it allows us to mimic, the trauma type of memory, but still in an ethical way. And I think nowadays with these technological advances like the virtual reality and some research groups like even combined it with VR, so to make it more immersive, so people can have more vivid immersive feeling of their experience. So this is the paradigm we use, and then we can manipulate sleep after the emotional experience. And we use TMR, like for example, we can first is directly reactivate the aversive memory or the negative memory. For example, in the cue target paradigm, to replay the cue, can be a spoken words to the sleeping participant. And alternatively, before the TMR and sleep, we can have some like interference learning or counter conditioning. For example, the word, at the beginning, it was associated with aversive memory. But next, we can pair the word with a positive memory. So this can be called like a retroactive interference, basically some new learned memories to interfere with the older aversive memory. Also, we can call it like a counter conditioning. So we're pairing a stimuli of opposite valence to the cue word. And then during the sleep, we can play this cue. So for now, the cue has been linked with two types of memories, right? So one earlier aversive memory and one recent positive memory. So we can replay the cue to the sleeping participant and try to reactivate the recently acquired positive memory. So this is our recent attempt to use TMR, to weaken the earlier acquired aversive memory during sleep.
Mm-hmm. I mean, and this I know you refer to as memory updating. And so there's a lot to unpack in there. I know that you've done it in two different ways, at least. So you have two very nice papers where one is where you, as you said, you have a sound first paired with something aversive and then subsequently paired with something positive. And then you play that sound in sleep and you're hoping that it will update so that the negative association is weakened and the positive association is more dominant. And in fact, that is what you find with that manipulation. In that case, when we read those papers, first we were very excited by the finding because obviously it has lots of important implications and possible uses even. But also we wondered, how did you know that it wouldn't just strengthen the initial negative association? And would it be different maybe in people, for instance, if people were depressed and so they had that kind of negative bias, would they be more likely to strengthen the negative association? Do you know, is that something you've looked at?
Yeah. Thank you. I think that's an important question. Given the cue is linked with multiple memories, how do we know which memory are we reactivating? In the paper, so we have like additional analysis to help us to provide evidence. For example, we found like the theta responses, theta power elicited by the cue and preferentially predicted positive memory. And also, when we look at like individual items, we found that valence strength of the emotion can be an important factor. So for example, if the positive memory is very positive, but the competing negative memory is kind of like weaker, then what we have is the cueing will reactivate the positive memory. But also we found that, in certain cases, when the initial aversive rating is very high, but the competing positive is not that high, then we can indeed, have some backfire effect. So it's reactivating the earlier, like the aversive memory. I think here, the emotional valence can be an important factor, but probably what it's suggesting is that, it's a salience. Probably, salient memory will be professionally reactivated during sleep. And another idea we had is that, for the system level consolidation, right? What we talk about is that sleep will reactivate and consolidate recent memories. And in our case, what we had is the positive memory being the recent learned memory. So which will also make them more susceptible to cueing and the reactivation. So indeed, we also got this question from the reviewers, how do we know which memory will be reactivated? So it can be the emotion or it can be the temporal order, right? The older versus the recent. So that's why we had a follow-up study. This is also unpublished, where we had like actually both orders. For example, people can learn like negative followed by positive. So only in this study is a behavior study, so we don't have the TMR component. But our findings suggest it is the temporal proximity that is more important. So in our like original finding, we have negative followed by positive. So the TMR reactivate the positive and weaken the negative. And in the subsequent follow-up study, behavior study, and if we reverse the order to have positive followed by negative, then the sleep also kind of consolidates the negative part. So consistent with system level consolidation, the sleep will consolidate what we learned recently.
That's really interesting. So it seems like, at least in this follow-up study, it's suggesting that recency is more important than the actual salience or strength of the memory. Is it all in healthy people that are not depressed?
Yes, all healthy people, yeah. We're thinking, recently to recruit depressed or subthreshold depressed population. And I think, the situation may be different here. And actually, I think 2016 and 2017, so a group from Switzerland, they published a paper on TMR and adolescence anxiety. And they found that over time, for healthy people, the TMR can have some benefit. But for the social anxiety group, they do not have the effect. So I guess, this is again linked to our, there's the existing scheme, right? We talk about the schema. So this can significantly bias how we interpret, how we think about the external event. And when people have this existing schema, so maybe the TMR of our one night of stimulation may not be sufficient to reverse this existing maladaptive schema.
Yeah, I think it's a really important question. It's something that we are working on as well. And we have done some TMR of positive memories in people with not clinical depression, but just low mood. And we are still looking at preliminary results that are not published, but it does look like it doesn't appear to strengthen those positive memories in the way that you would expect that it should in healthy people. We don't know, but it may be down to this kind of effect that you're talking about. So if they have an overall negative schema, they have a bias towards negative things, strengthening negative memories, it's going to be harder to strengthen positive memories. And it may be, so you already alluded to it may be that one night is not enough and it needs more nights of manipulation, or it may be that we need to make the manipulation stronger in some other way. But I think this is a very interesting question. But I think what you've done where you're updating the memory, you already had one association and then you're kind of switching it to another. If that really depends more on recency, maybe it will depend more on recency in the people with depression as well. So I think it's a great approach. You had another very exciting study with a very similar method where the updating actually occurred in sleep. So you didn't teach them the positive information before sleep. Can you talk a little bit about that and how it differs and what you found?
So basically, a cue can be a word and the target can be an aversive image. And then during sleep, we play the cue, during sleep, just as a TMR. But there we do a tweak. So basically, to present a positive word to be paired with the memory cue. And as a control condition, we also have like a neutral word to be paired with the cue word. And after people wake up, we give people like a valence judgment. So basically, present them with a cue word again and ask them like whether they feel like negative or neutral about this keyword. So we found that like if, during sleep, during non-REM sleep, if the keyword has been paired with positive words, then people will feel less negatively towards the keyword. But this effect was not seen on the neutral pairing condition. So this is what we call affect updating. I think, what's nice about this paradigm is that we don't need a participant to go through the counter conditioning or the interference learning while they're awake. But here we can, just play the positive word during sleep to be paired with the aversive memory cue to update the emotional valence or how people feel about the keyword. And actually, there's early studies showing this possibility as well, basically to pair like aversive odor. They instead of using sound or auditory cue, and they found that, again, people's emotional feelings towards the stimuli can be changed as a result of the conditioning. And I think, again, like broadly, this is consistent with the research finding, in the sleeping brain, the sleeping brain still preserves, a remarkable capacity to process like semantic and affective stimuli.
What do you think is actually happening? I mean, how do you think it's actually working? So if we think about schemas, is that a good way to think of it? So, in the sleeping brain, yes, it processes that emotional stimulus. And so it's activating positively valence associative network of ideas. And that is somehow then bleeding into the other sound, the network the two are merging. So is that how you think of it, or?
Yes, I think it's more or less the same. So one is, as you mentioned, kind of like create a positive schema. And so then like other stimuli, like aversive memory cue that appeared in the schema will also be colored as positive. So this is one possible mechanism. And I think, because what we did in the experiment is like a mini block design. So in one block, there's always like a positive pairing. And another block will always be like neutral pairing. So I think this is definitely a possibility because the block design, during that mini block, is always the positive word being played. So it can have such a schema. Another possibility is, the more stimuli-specific conditioning. This is another like associative learning, right? Like one positive word followed by one aversive memory cue. And if the sleeping brain processes the positive valence, so it will be spread it to the following aversive memory. And after repeated rounds of this conditioning, so we can change, the emotional valence of the aversive cues.
I mean, I guess, so one thing that I had written down to ask you related to this, I've kind of asked already, but I just check if there's anything else, is with patients. So, if we're thinking about this updating as a kind of a treatment for, I don't know if you think of it as a potential treatment for depression or for PTSD, how do we think it might be different? And what can we do to try and optimize it for patients, I guess?
Just by doing TMR itself is never sufficient. Like psychotherapy, right? People need to have very professional guidance and good therapies, and also requires the patient's efforts and hundreds of hours to change, their schema and change their behavior. So probably, given it is so hard to change one's knowledge schema, it would be kind of naive to think like a single TMR without additional, can be the solution. But I think, the interesting and the promising here, it offers one additional avenue to complement the daytime and the existing therapy we have. So the therapy lasts for weeks. But then, their TMR at home also lasts for weeks. So with this intensive dosage of daytime and nighttime intervention, there is reduction, improvement of the symptom. I think if we really talk about the patient and its clinical implication, we still need lab mechanism study, but also to think about this scaling up and the real world, probably, these wearables and tight band at home setting TMR, and to be combined with this professional psychotherapies will be the solution. Probably, more effective, like what we do in the lab, like one night of TMR can make some difference. But if we talk about patient population in the real world setting, probably, we need many other things to be combined with TMR to make it work.
I think I agree with you. I mean, I think what you're saying is, use everything that you can to try and tackle these mental health conditions and combining things. So I do agree with you. But that brings me to a related point, which is we've already touched on the fact that you find it's the interaction between REM and slow wave sleep that were important for the first study that we talked about, so that for altering implicit bias. I know that all of your work on updating negative memories to make them more positive has been in slow wave sleep. And I don't think you've had any interaction with REM in those. Have you found that REM explains any of your results at all?
Yeah, so in the updating one, I don't think we look at REM, but in the counter-conditioning one, like in the weakening aversive memory paper, again, this is prompted by a reviewer. We did look at REM, and we found that REM can also predict the benefits. So the REM subsequent to the slow wave sleep.
Okay, and which one is stronger, the REM or the slow wave, or the interaction between them?
it's only the REM after the slow wave QE. So we did not find the product. And in another unpublished data, not on emotional memory, but on like memory transformation. So we also found the ratio between slow wave sleep and REM kind of predicted the memory transformation. So again, we tried the product, but the prediction was not significant. It's only the ratio one that worked. So again, I think first we need to consider both slow wave sleep and REM sleep.
Yeah, but I think that we would agree that what that's telling us is that, it might be subtle and the data are noisy and we don't really understand what's going on, but both sleep stages are somehow important. And the relation between them, how much of each we have is somehow important, right? For many years, I never understood why people looked at percentage of sleep stages instead of just the minutes of sleep stages. I always kind of resented that they didn't just look at the minutes. But now I think if you think about the night of sleep as a more holistic thing, and you acknowledge that it's not about the minutes necessarily, it's about the structure of that.
The structure, yes, I agree. Yeah.
We're not really measuring that structure usually in a very sophisticated way. If we're just talking about, the ratio of REM to non-REM or the product, it's a very clunky way, but we're trying to start. The fact that you're finding that those kind of measures explain something in your data tells us that it's the structure of the night of sleep. And we maybe need to be thinking about more sophisticated ways to look at that. I guess what I would ask then is, given that you have that finding, do you have ideas about the contribution of REM? I mean, what do you see as the contribution of slow wave and the contribution of REM?
Yeah, I think it's a big question, and more our attention has been devoted to REM. I think, and again, there are like mechanisms, especially from the animal literature, right? Because they can take a really like detailed, specific way to the neurocircuitry, to the neurochemical environment, but, which we lack the precision when we do like human research. So I would say still like, I don't know, but I think at least the evidence is suggesting that the slow wave sleep via this system level, like triple coupling between like different neural rhythms. So is optimal for memory reactivation and presumably like transformation from like hippocampal dependent to more the interaction between the neocortex and the hippocampus. And then in the REM sleep, when we talk about emotional memory, when the animal work there, the results showed there is a decoupling between the hippocampal and the amygdala and the theta responses. So basically there are this anti-phase ongoing. So this is argued maybe optimal for like emotion attenuation. But again, I think, first the evidence from animal and the human can be a huge gap. And with human, we have, a lot of data like on the REM and the emotion memory, or sometimes the interaction between slow wave sleep and REM on the emotion. But still, in general, I feel like REM is a mystery to us compared to our understanding of non-REM.
Mm-hmm. So, I mean, it's clearly there's a lot for us to try and understand there. But I guess then the next question is, do you think that we could manipulate slow wave and REM within the same night or within the same person on different nights? Or should we just not do that? Because we have already said that we think once we start a manipulation, it kind of continues into the subsequent sleep stages. What do you think about all of that mess?
Yeah, I think at least we can try this sort of manipulation. So, like some work will use this continuous TMR, right? Like basically they don't rely on any specific sleep stage, like at a home setting in the early studies. They do play the TMR cues overnight, but sometimes they don't find the effect. But I think, at least in the lab setting, I don't think we have such a study, to play the cues during both slow wave sleep and during the REM sleep. So I do think, this kind of study is necessary and important for us to have. But on the other hand, on the REM literature, people are arguing if we have like a fragmented REM or disrupted REM, or even if the cue will disrupt the ongoing like slow wave sleep, it will do harm rather than the benefiting. So maybe like we need to think carefully how to subtly manipulate without disrupting our ongoing sleep. So I think, we really need more work along this topic.
Yeah, I agree. So just kind of pulling back then from the emotion stuff for a minute, but still talking about updating and kind of schema manipulation. I know that you've done some other really lovely work on things like self-referential concept and how you can change how people feel about themselves and also people's interactions with healthy snacks and, what their opinion of it compared to when they hear someone else's opinion of it. Could you talk a little bit about some of that work?
Yeah, sure. In the self-referential memory, is the first idea is whether we can kind of like strengthen people's positive self-evaluation via this like cueing during sleep. And we found that in the nap session, we play like the positive personality traits such as like smart, brilliant, brave, and ask them, do you think this apply to yourself? So a typical finding is that for a healthy population, they would endorse more positive than negative traits. And also, if you give them a surprise memory test, they will retain more positive traits than negative traits. And again, I think this is consistent with what you mentioned, like because our positive self schema, right, establish the above average effect, suggesting that we tend to think we are better than the average person. So a positive self-esteem is good for our mental health. However, for people who are depressed, they would show the opposite pattern. And also, if you give them a surprise memory test, they will show a negative memory bias when they recall these personality traits. So in our TMR study, after, people rate this personality trait, we'll just select, the positive personality trait and replay this positive personality trait to the sleeping participants. And after they wake up, we give them this test again. We found that it makes them faster in endorsing the positive personality trait. So some evidence suggesting that the cueing facilitated the positive self-evaluation. We want to follow it up basically to same procedure to depressed population. But we suspect we may have the similar issue, because of we can think about it as an intervention, for depressed people when they have low self-worth and self-esteem. Maybe this positive personality trait reactivation can, increase the positive self-evaluation from an intervention perspective. But as you just mentioned, the other possibility can be true, right? Which is the existing schema may make them unable to process positive personality trait or even process the positive personality trait as negative. So maybe when we present the positive trait, they're actively thinking, it's not me. So it's like they spontaneously counter this reactivation.
Do you have any evidence to suggest they do that?
So we haven't done the study with depression, but we collected some data with substressor depression. Again, this is preliminary results suggesting that we do not show the benefits with substressor depressed participants. So suggesting that what's happening here is consistent with what you mentioned earlier.
Yeah, that's interesting. So it's all kind of consistent. So in this population, we are going to have to try harder somehow. But it's very nice that it works in the healthy population. And I mean, I see that the logic is exactly the same as in your implicit bias paper, where you're just getting the brain to strengthen or practice the positive self-referential concept and then hoping that will apply to them and they will kind of latch on and it actually does. It's a really lovely additional avenue for using this to change how people feel about themselves.
Yeah. And another one you mentioned that the snack study is basically follow another research line like the social learning. So basically, as we know, people are like to show like social conformity. Like for example, especially in new environments, right? I follow what other people do. Like for example, in our like food selection, for example, just to think we're on the Yelp, right? We'll choose a restaurant people would rate highly. So basically, we ask people to rate, how they like certain snacks, and then they will how their peers like or dislike the snacks. And we pair a sound with that social learning process. And then we play the sound again, like in the TMR setting during their sleep. But here we did not find the main effect of TMR. So basically, we found the main effect of social learning. So they will change their attitudes, change their evaluation, basically according to their peers. But the TMR, whether cueing or not, did not have a main effect. But, some other analysis we did in the study is found that like the sigma power, like the spindle-like EEG activity can predict the preference change. So we think it's another, interesting extension, to apply TMR in like the social to be combined with social learning.
Yeah, and it relates somewhat to Anat Arzi's studies with cigarettes smoke, doesn't it? Where she's shown that she can use odor TMR to kind of help to train people to find the smell of cigarette smoke more aversive, and they're more likely to continue to not smoke when they've given up smoking. I think that's how the study was, basically. So it's not the same thing, but it's related to this, can you change people's social behavior, whether it's snacks or smoking? Yeah. So, I'm conscious that we've covered a lot of material, but I also want to ask you a couple of final questions. So the first one is, where do you really see all of this going? We've talked a little bit about potential applications. We've talked about the fact that we can update people's schemas and people's associative networks for how they see themselves, how they see the world, how they see their places in the world, and their emotional state as well. Is there more? Where else is this going? How practical is it going to be used?
Yeah, I think that's a question first. Still need more research and evidence, but I, tend to be bold, and especially, by this rapid development of this technological advances, right? Like these wearables, not just the headband with EEG signal, but also, for example, the smart watch, and even like the so-called like smart bedding, right? Like our mattress, our pillow can be developed in a way to detect either like body movement or the brain activity. So I think, in terms of practical, then probably it's no longer, the lab studies, we hook people up with 64, 128 channels and monitor them overnight, which are quite labor intensive. But we can, in the home setting, which we sacrifice the accuracy and probably much of the mechanistic insight, but to scale it up with, either wearables or these smart devices, and there can be a lot of the possibilities, or in the environment to monitor our sleep activity and also to deliver sound or like odor, or to be combined with like pre-sleep activities such as like mindfulness training, meditation, like breath training, can either like mental health wise or like cognitive function wise to help us like restore, recovering night of sleep. So I think, but this also requires, not only psychology, but also like with neuroscience and engineers to move forward, along this direction. But I think this will be a really exciting and promising avenue. And I think, for researchers in engineering, they will also be very excited to collaborate with us to exploring these opportunities. And the second, I think, is, as you mentioned, still we don't know much about the mechanism, about REM, how the different sleep stages role in memory and the emotional functions. So again, probably with the development of like AI and the deep learning, we have more powerful ways to know, what the different sleep structure is, and to link it with our like lab results, because we can have like precise measurement of like memory and emotion and their like physiological responses to gain like a mechanistic understanding of what's going on in the brain, like during sleep, how that reshape our memory and emotion. And eventually, maybe these two lines of research can go along together in a very nice way and a creative way, eventually, again, to help people's cognitive function and the mental well-being in the daily life settings. And I think, this is not just to the clinical population, right? Because the clinical issues, probably they only have a very small proportion of the daytime events and the distress we have in our daily life. So maybe this can be applied in everyday setting, not just when someone already developed into the disorder, right? The reason we look at into this high-risk depression, and you mentioned like borderline, is like to prevention, right? Because once they develop into the like MDD, major depression disorder, then the cost will be very high and be very difficult and challenging to reverse. But probably, we can start with already in the daily, everyday setting, kind of like from a prevention perspective approach.
And maybe kind of a self-medication approach where people, they realize they're feeling a bit down, and so they can just turn this on for a couple of nights and see if it helps a bit.
Exactly.
Yeah.
Yes. Yeah.
I think that's a really nice way of thinking about it. I really hope you're right. Yeah. So I think that's a wonderful place to stop. So thank you so much. This has been a great conversation.
Yeah, thank you, Penny.
You've been listening to the Sleep Science Podcast with me, Penny Lewis. Our guest today was Professor Xiaoqing Hu from Hong Kong University. If you have a question about the content of today's show, please feel free to get in touch on social media. From me and everyone at the NAPS Sleep Lab in Cardiff, thanks for listening and see you next time.